Good morning, students. Today is Swaminarayan. In the previous lecture, we have completed up to 7.2. Let us revise the fundamental principle of counting. I am writing in short FEC. And then, students, we will revise permutation. Now, just recall, in exercise 7.1, we have discussed fundamental principle of counting. Suppose an event can occur in m ways. After that, the second event can occur in n ways, and correspondingly after that, the third event can occur in p ways. Then the total ways in which all the three events can occur in order is n into p. This was, students, the fundamental principle of counting. Suppose an event can occur in m ways, after that the second event can occur in n ways, and correspondingly after that the third event can occur in p ways. Then the total ways in which all the three events can occur in order are n into p. What is permutation? Given are n items, objects or things, out of which r items can be arranged. Given are n items, objects or things, the total ways in which r items can be arranged out of given n are called permutations of r items, denoted by NPR, and the formula was n factorial upon n minus r factorial, and n factorial is nothing but the product of first n natural numbers, and exception 0 factorial is equal to 1. This is the concept which we have already studied, students, in exercise 7.1 and students 7.2. This is the basic fundamental concept which we have already studied in exercise 7.1 and 7.2. Now we are going further. We are starting exercise 7.3, answer 1. Now what is the sum? Given are digits 1 to 9. Using these digits, how many 3 digits number can be formed without repetition? Given digits are 1 to 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. We always write total digits as n. Now we have to form 3 digits number. 3 digit numbers. So I draw 3 boxes: hundreds place, tens place, and units place. Now, without repetition, students, I am doing the sum in 2 ways. First, I am going to apply fundamental principle of counting, because 0 is not a digit. So, the hundreds place can be filled in 9 ways. Out of 1 to 9, any one of the digit can occupy hundreds place without repetition. Without repetition, suppose 4 is arranged. So for tens place we have 8 ways, and correspondingly for units place we have 7 ways. So the answer is 72 into 7, which is 504. So total 3 digit numbers formed are 504. This I have learned, students, according to fundamental principle of counting. Here we have applied FPC. Now what is the alternative way? Or given are 9 digits, out of which I am arranging in 3. Given are n items, if I want to arrange in r items, it is NPR. Given are 9 digits, if I want to arrange in 3 digits, then the total permutations are 9 by 3, which is nothing but 9 factorial from 6 factorial, so 9, 8, 7. This will also give us 504. So given are n items or objects out of which I am arranging any r, then this can be done in NPR ways. Given are 9 digits, I want to arrange in 3 digits, so it can be done in 9p3 ways. Suppose I want to form 4 digit number, then 9p4. Suppose I want to form 8 digit number, then 9p8. So this is how we have done the sum by fundamental principle of counting, and now I am doing by permutation. This is how, students, we have applied the formula of permutation. So the final answer remains same. Now, students, second sum. Without repetition, how many 4-digit numbers can be formed? So it is without repetition. How many 4-digit numbers can be formed? So here, when I write given digits, students, I have to start with 0. So the total digits will be 10. In the first sum, they had already specified that the digits were 1 to 9. Here, when no specification is given, students, then we have to include 0. So 4-digit numbers, 4-digit numbers, and that too without repetition. 4-digit numbers and without repetition. So I have to draw 4 boxes. Thousands place, hundreds place, tens place, and units place. Okay, students. Now I am using only permutation. In thousands place 0 cannot come. So from 9 I can arrange any 1 digit. From 9, 1 digit can be arranged in how many ways? 9p1, and that is 9 ways. Always remember, np1 is n. np1 is n. 8p1 is also 8, 10p1 is 10, 100p1 is 100, 57p1 is 57. Now, out of this 9, any 1 digit is arranged. Suppose 6 is arranged. So here I will have 8 options including 0. Now I will have 9 options. In hundreds place, in tens place, in units place, 0 can come. So now I am sparing with 9 digits and I have to arrange in 3. So cumulatively these 3 places out of 9 can be arranged in 9p3 ways. And that is 9 into 8 into 7. And that is 504. So total 4-digit numbers will be 9p1 into 9p3. Why into? Because I am arranging first digit and the remaining 3 digits. And means always multiplication. So 9 into 504. So this is 4, 5, 3, 6. 9 5s are 45. And 4 into 9 is 36. So 4500 plus 36. So 4, 5, 3, 6. Even if I would have gone by FPC, students, my answer would have remained same. Why 9p3? Say out of 1 to 9, one of the digits is arranged. So this bracket will spare 8 digits including 0, 9. So these 3 places and I have 9 digits. So I have to arrange any 3. So out of 9, any 3 digits can 4. The thousands place can be filled in 9 ways. So the total ways are 9 into 514, and that gives us 4, 5, 3, 6. Okay, next question, students, sum number 3, and it is a very important sum. Given are digits 1, 2, 3, 4, 6, 7, then how many 3 digits number will be formed which are even? Okay, answer 3. Given digits 1, 2, 3, 4, 6 and 7. So n is equal to 6. Sorry, n is equal to 6. How many even 3-digit numbers, conditional sums? Even 3-digit numbers, and of course without repetition of digits. This type of sums forms the core concept of JEE. Students, 3-digit numbers, so I will draw 3 boxes and write hundreds place, tens place, and units place. Now, how will you know that a number is even of 3 digits? Suppose I write 316. Using this digit, it is an even number. Yes. How will you know that this number is even? A number is even provided its units digit is even. Yes or no? A number of any digit is categorized as even number provided students the units place is even. So in this type of conditional sums, students, we have to start with the condition. So here I have to go with the condition. So I have to start filling the units place. Now how many even digits we have? 2, 4 and 6. So out of 3, any one digit can be arranged in 3 even ways, and that is 3 ways. Correct? Now out of 2, 4 and 6, suppose 2 is arranged. So now remaining are 5 digits, out of which I have to cumulatively arrange any 2. So 5p2, and that will be 5 into 4, 20. So total ways will be 20 into 3, and that is 60. So total 3-digit even numbers formed will be 60, 60. Now 5p2, so you have to write decreasing 2 factors. So 5 into 4, 20, or you simplify. 5 factorial upon 3 factorial. Reduce 5 up to 3, your answer will be same. So this is what, students, we have to do. So these are called conditional sums. And students, for conditional sums, we have to always start with the given conditions. Okay, now we do question 4 and question 5. So students, one has to be very, you can say, attentive in doing this sums of PNC, permutation and combination, and it demands extra attention as well as concentration. Now, using digits 1, 2, 3, 4, 5, how many 4 digits numbers can be formed? Okay, students, answer 4. Given digits are 1, 2, 3, 4 and 5, and of course without repetition. So I am writing n is equal to 5. First part of the sum, 4-digit numbers without repetition. Okay, students. So I have to draw 4 boxes. Thousands place, hundreds place, tens place, and units place. Now 0 is not a digit. Given are 5 digits and I have cumulatively arranged any 4. So from 5, 4 digits can be arranged in 5 be 4. So this is 5, 4, 3, 2. 5 be 4, so write 4 decreasing factors from 5. So this answer is 120. So total 4 digit numbers formed are students 120. And that is nothing but very simple students. It is the simplest part, the sum. Now, how many of these numbers are even? Part B. 4 digit even numbers, and of course, without repetition. So again, students, I am drawing 4 boxes. Thousands place, then hundreds place, then tens place, and then units place. Even digits are only 2. So out of 2, any one digit can be arranged in 2 even, that is 2 ways. These are again conditional sums. And students, for conditional sums, we have to start with the given condition. Students, for conditional sums, we have to start with the given condition. Now, so out of this 2 and 4, one digit is arranged. So bearing 1 and other 3, 4 digits are left cumulative, and out of that again 3. So 4p3, and that will be 4 into 3, that is 24. So total even 4 digit numbers is equal to 24 into 2, and that is nothing but 48. Now, one extra point we are writing: total or 4 digit numbers will be total minus given, which will give us 72. This is not asked. It's clean, you can write. Students, we are not asked to find all 4 digit numbers, but still, students, we have written. So you can be asked to find total numbers, you can be asked to find even numbers, as well as you can be asked to find odd numbers. So students, your revision of basic, revision of concepts must be there. Again and again, students, you should revise. The more and more you revise the concepts, students, you will definitely enjoy this type of sums. Okay, now students, we are doing sum number 5. Out of 8 persons in a committee, we have to choose one. You can say president and one vice president. In how many ways we can do? And you can say one person does not have 2 positions or portfolios. 8 persons are given, students. Answer number 5. Suppose 8 persons are A, B, C, D, E, F, G, H. One president, Mr. President, and one vice president. Again, I am doing the sum in 2 different ways. in the first part, students, I am going for fundamental principle of counting. In the first part of the sum, students, I am going for fundamental principle of counting. Now for president, I have 8 choices. So Mr. President can be chosen in 8 ways. Suppose D is Mr. President, so for Vice President I have 7 ways. So total ways are 8 into 7, and that is 56, in which Mr. President and Vice President can be selected. Alternatively, I go for 8p2, then also the answer is 8 into 7, and that is 56. From 8, any two persons can be arranged in how many ways? 8p2 ways. So suppose we were to select president, vice president, and you can say the chief officer, then 8p3. So this is very simple. From 8 persons, any two persons can be arranged in 8p2 ways. And 8p2 is right, 2 decreasing factors from 8 into 7. The answer is nothing but 56. So this type of questions, once understood, students, are very easy. I have done the sum first by fundamental principle of counting, and alternatively from 8 persons, any 2 persons can be arranged in 8p2 ways. So the answer is 56. Now students, we are doing questions 6 and 7. Our next approach is to do questions 6 and 7. Now, pay attention. The sixth sum. Students, in sixth sum, we are given. In the sixth sum, we are given a ratio n minus 1 p3 is to n p4 is equal to 1 is to 9. Then find students n. Okay, students, we are supposed to find n. Now remember, if it is 8p4, we write 4 decreasing factors from 8. So 8, 7, 6 and 5. Suppose it is xp4, we write 4 decreasing factors from x. Isn't it? So this, my students, all of you remember. So n minus 1 p3 means write 3 decreasing factors from n minus 1. So it will be n minus 1, n minus 2 and n minus 3. np4, so write 4 decreasing factors from n. n minus 1, n minus 2, n minus 3 is equal to 1 by 9. N minus 1 gets cancelled, n minus 2 gets cancelled, n minus 3 gets cancelled. 1 upon n is equal to 1 upon 9. So n is equal to 9. 1 upon n is equal to 1 upon 9. Therefore, students, n is equal to 9. This is going to be very simple. Okay, 7, part A. 5 PR, answer 7. 5 PR is equal to 2 into 6 PR minus 1. 6 PR minus 1. It is 2 into. Just find the value of R. Okay, students. Now, if I apply the formula of NPR, which is n factorial upon n minus r factorial, so n is 5. So this will be 5 factorial upon 5 minus r factorial. Apply the formula of NPR. 2 into this will be 6 factorial upon 6 minus r minus 1 factorial. Here, I cannot write the factors as I have written in sum number 6 because R is a generalized term. Students, R in this case is a generalized term. Now, reduce bigger factorial terms up to the smaller factorial terms. That is the logic. If I simplify this, we return to 7 minus R. That much you can understand. Now, out of 5 factorial and 6 factorial, what is bigger? 6 factorial. So, keeping this 5 factorial as it is, this is written as 6 into 5 factorial. Now, out of 7 minus R and 5 minus R, which is the bigger term? Of course, 7 minus R. So, reduce it by 1. Then 6 minus R and reduce it by 1, so 5 minus R. So logic concept of this type of sums is to reduce bigger factorial terms up to smaller factorial terms, and then students get it cancelled. So now I can cancel 5 factorial and 5 factorial, 5 minus R factorial from both the sides. So here on cross multiplication, 7 minus R into 6 minus R is equal to 12. Now one simple way is to go for expansion and then factorize and get the answer. One simple traditional way is to factorize, expand and get the answer. But I have a shortcut technique for you students. My left hand side is consecutive decreasing factors. So 12 can be written as consecutive decreasing factors. Means 12 written in consecutive decreasing factor is 4 into 3. Compare bigger and bigger terms, smaller and smaller terms. Your answer will remain same. So R is equal to 3. Even if I write 6 minus R is equal to 3, then also I will get R is equal to 3. This comparison, students, this approach of comparison can be done provided both the sides are consecutive factors. Otherwise, suppose this was written as 15, then 15 cannot be factorized as consecutive factors. Suppose it was 24. 24 is not factorized as consecutive factors. So be careful. This shortcut technique is really applied if both the sides are consecutive factors, otherwise not. Okay students, now the second part of the sum. Now we are doing the second part of 7 sum, part 2. 5 PR is equal to 5 PR is equal to 6 PR minus 1. Okay, that 2 is removed. Now students, pay attention. Again, I am going to apply the formula of NPR. What we are going to do, then students, we are going to apply the formula of NPR. So this will give us 5 factorial upon 5 minus R factorial is equal to 6 factorial upon 6 minus R minus 1 factorial. This is 7 minus R factorial. So 5 factorial as it is, 5 minus R factorial as it is, this is greater. So 6 into 5 factorial, this is greater. 7 minus R, 6 minus R, 5 minus R gets cancelled, 5 factorial gets cancelled. 7 minus R into 6 minus R is equal to 3 into 2. Compare bigger and bigger factor. 7 minus R is equal to 3, so R is equal to 4. This comparison approach is only taken when both the the sides have consecutive factors. Otherwise, this comparison based approach, students, cannot be taken. So let us revise once again what is FPC. Suppose an event can occur in n ways. After that, the second event can occur in n ways, and after that, the third event can occur in p ways. Then the total ways in which all three events can occur in order is n into p. This is the fundamental principle of counting. The total arrangement of r things out of given n things is called permutation of r things, which is denoted by NPR. The formula of NPR is nothing but n factorial upon n minus r factorial. And n factorial is nothing but the product of first n natural numbers. If I take 5 factorial, then it is the product of first 5 natural numbers, which is 120. If I take 100 factorial, it is product of first 100 natural numbers, which cannot be found out even in a simple calculator. We have to use a scientific calculator to get 100 factorial. In short, one exception, we have 0 factorial is equal to 1. We have an exception. 0 is not a natural number as far as factorials are considered. We always have students natural numbers. And the formula for NPR is nothing but n factorial divided by n minus r factorial. So permutation and fundamental principle of counting are synonym, but in exercise 7.3 students we have used permutation. Out of 8 things, 4 things can be arranged in 8p4 ways. Out of 10 things, 5 things can be arranged in 10p5 ways. Out of 7 things, and 3 things can be arranged in 7p3 ways. This is how students we apply the concept of permutation. So here I advise you do the first solutions twice. First time you do with looking, second time you do without looking. And in the next lecture we will conclude the exercise 7.3 and start the concepts of combination. Thank you students, we conclude the lecture.